Good morning, good afternoon, everyone. Welcome to our webinar today on Revolutionizing Utility Preparedness with Storm Risk Analytics. My name is Andrea Berg, and I am your host for today. Before we begin, I'm just going to go over a few housekeeping items. First, we are recording this webinar, so for anybody who wants to watch this after, want to go back or share it with colleagues, we will be sending out the recording in a few days after this webinar. We will have an opportunity for any questions at the end of this webinar. So if you have any questions at any point throughout the presentation, please go ahead and use the Q&A feature on the right-hand side of your screen in WebEx, and you can ask those questions at any point, and we'll get to them at the end. And finally, we will have some poll questions throughout the presentation. So keep an eye out for those poll questions that will be launching throughout the presentation. So with that, I'd like to introduce our moderator for today, Kevin Stinson.
Hi, hello. Thank you for joining today. Let's go through a brief. We went through the housekeeping notes, go through the agenda. We will start today with Nick Wilson, who's the Director of Product Management here at DTN. And then we will transition into Brad Nelson, who's our Solution Engineer here at DTN. He will walk through a case spotlight on the advantages of Storm Risk Analytics. And then we will work with our partner, Esri, and Pat Hull, who's the Director of Industry Solutions in the Electric Division. So we have a full agenda today. And with that, I'd like to pass it over to Nick Wilson.
I appreciate the warm welcome, Kevin. Good morning, good afternoon to everybody across the world joining us. My name is Nick Wilson, DTN's Director of Product for Weather and Climate Intelligence. I'm based out of DTN's headquarters in the Minneapolis area. Across my 20-year career journey, I've worked largely at the intersection of weather and environmental challenges and those that they pose to the electric power industry. So excited to share a little bit of my insights and perspective with you all today. As a starting reminder, we have noted here the $183 billion problem. In 2024, there were more than 27 natural catastrophes and environmental disaster events that cost and had a financial impact greater than $1 billion. In total, all of these catastrophes totaled $183 billion. And as you would expect, the power utility industry was responsible or victim to a substantial brunt of those impacts, given the broad nature of their above ground assets and infrastructure and the criticality in which they are supporting our entire economy, not only in the United States, but globally. Pulled together some statistics here. As you can imagine, utilities are investing heavily in capital expenditures in order to improve the resiliency and hardening of their assets and infrastructure so that when the next storm of similar size hits, the opportunity or probability of power continuity improving. As you can see in this graph, unfortunately, I only had statistics graphically through 2019, but the CapEx expenditure growth numbers here representative from 2003 to 2023. You can see that on the bottom, the dark blue operations and maintenance costs have increased slightly with inflation adjustment. Customer expenses have also largely stayed at similar levels, but you can see that since the early 2000s, capital expenditures have increased in upwards of 160%. And just alone, although not noted on this graph, between 2022 and 2023, there was a $6.5 billion increase. So there's a lot of aging infrastructure that's being replaced, different lines, transformers, substations, and the like. There's new enhanced power settings, equipment, and other enhanced grid resiliency measures that are being taken in order to better handle and minimize the impact of extreme weather, as well as better manage the intermittency of renewable energy. If we go to the next slide, Kevin. At the same time, you would expect that given these substantial increases in capital expenditure investment, that you would see commensurate improvement in power reliability and performance of the grid. But quite surprisingly, we're seeing actually the inverse. You can see that significant bulk power outage data going back to 1992 through the early 2010s sees a substantial increase in the number of weather-related large power outages. Then we can dive into a little bit more detail, picking up where that graph leaves off at the start from 2013 through 2023. Naturally, there's interannual variability as far as the severity and frequency of significant storm events. But if you take the average of the 5-year period between 2013 and 2017 and compare it to the past 5 years between 2019 and 2023 and the most recently available data from the EIA with the US government, you can see that not only are we seeing an increased number of outage oriented events, a 33% increase, that's also driving a 7% increase in SAIDI, or the average duration that each electric customer faces on an annual basis. So what this story tells is, despite incredible capital expenditure investments to harden the grid, Mother Nature is still outpacing our efforts. The increased severity and frequency of storm events is something that we can't avoid, and a combination of hardening and predictive solutions is needed in order to best position a utility in order to provide the highest levels of service to their customers. If you go on to the next slide, Kevin. DTN as a provider, prior slide, sorry. So DTN has partnered with utilities across the world to implement utility-specific outage prediction modelings and capabilities. And for illustrative purposes, I've grabbed here some anonymous outage per storm incident event data that's distributed across an 8-year period for utility in the state of Alabama, as well as a utility out of the state of New York. And the main message here is significant power outage events caused by extreme weather are happening every month, any time of year. There is no seasonality to these issues, whether it's a tropical cyclone or hurricane landfall in the summer and late fall, whether it's a significant ice and wet snow oriented event in the winter months, shoulder season events with high winds, lightning threat, and potential. Utilities, no matter where they're located across the United States or globally for that matter, have exposure at all times. So they always need to be on their guard. Next slide. DTN also partnered a few years back with T&D World and Utility Analytics Institute to provide a comprehensive survey of emergency preparedness leaders in the electric utility industry. And what we found is that the common practices that utilities are taking, as expected and showed by that drastic increase in capital expenditures, is investment in infrastructure hardening and resiliency. With roughly half of utilities increasing investment in those areas. Maybe quite surprisingly as well, we see counterintuitively that utilities are not investing too heavily. Only 1 of 5 are investing in additional weather prediction solution capabilities, which demonstrates, given the challenges that hardening investments alone are taking, that there may be some misdirection as far as the utility strategies, as far as collectively improving the grid and their overall operations resiliency to storm events. Next slide. We also found from these survey results that utilities are quite open towards partnering with external meteorologists. More than 2 out of 5 utilities are making such investments. But once again, there's a large apprehension and wariness from the utility community to invest in internal data science capabilities. So, this is illustrated as a potential gap as far as solutions that could contribute to overall improvement in those SAFE and SAIDI scores. Next slide. DTN, we work with hundreds of utilities across the world that are serving, hundreds of millions of customers. And, we've had conversations with the emergency preparedness leaders in these organizations internationally. And it really comes back to the same 5 or 6 challenges that are shared across the industry, no matter where a utility is located geographically and what markets they're operating in. First off, utilities and decision makers and stakeholders across the organization are facing information overload. There's conflicting forecast information from the National Weather Service or their local National Meteorological Institute. They're working with different local media partners as well as other weather vendors, and everybody has their favorite mobile application on their smartphone in order to try to make a best guess as what the forecast is. So there's a lot of misaligned information to take decisions against. We find that many utilities don't have a common framework for objective criteria to declare storm events. The anecdotal story we always like to share is if you provided the same weather forecast information, the same impact oriented predictions across a utility's infrastructure for a forecasted significant weather event, and you put 3 different emergency preparedness managers in different rooms with that same set of information, they would each come back to their respective teams with a different strategy as far as how to approach, prepare, and respond to the event. So it's clear that, especially with mobile workforces becoming more common, distributed decision making across different functions and organizations, that there needs to be a cohesive plan. We also find challenges as far as the uncertainty involved in holding over crews for afternoon thunderstorm events, when and where and how many external or foreign crews, whether that's coming from mutual assistance or external contractors, need to be brought in. Emergency preparedness managers, one of the first things that they think about when a significant storm event is predicted is which events that have impacted my service territory in the past are most similar to that's forecasted. Oftentimes that information is recorded in Excel files or paper logs. It's time-consuming, challenging to refer back to those historic events and understand what decisions were made at that point in time, what the outcomes were, and how that could potentially influence the decision-making and scenario analysis in future events. There's also the challenges as far as messaging and communication to your customers so that you set expectations appropriately. And then, most investor-owned utilities, contentious partner being their state regulatory and public utility commission. There's a lot of information that needs to be shared in those post-storm reports to justify their pre-storm actions. The impacts of severe weather, wildfire, and other extreme events are highlighted on the right-hand side here. But the impacts, at the very minimal level, as far as customer power outage, lead to frustration, decreases in customer satisfaction score and lack of confidence, all the way to the extremes as far as liability and significant financial risk and impairment. Next slide. So let's talk a little bit more about outage prediction solutions. DTN has been partnering with industry and academic institution leaders since 2015 in building utility-specific outage prediction systems. And we believed and understood that we could adapt that approach to what we refer to as a community modeling system. So what you need in order to produce and create an artificial intelligence machine learning outage prediction model is a few ingredients. First off is what we call weather forecast reanalysis data. So typically weather models now are run at large scale on a gridded basis, and you can rerun the operational models back in the past using the data that you had available and recreate what the weather conditions were at any given point in time. So we can take that historic weather forecast data along with a utility specific asset and infrastructure data, as well as their outage management system information to geolocate incidents and damage, the cause of those faults, the duration of the outages, and other factors of interest. Then you also need to consider the things that are interacting and engaging with the assets and infrastructure and could be influenced through the impact of extreme weather, such as land use oriented information and vegetation management, such as tree proximity to lines, health of the vegetation, and whatnot. All that information or ingredients are brought together into a training data set that we run the historic events against, and specifically for a utility service territory and operating geographies, create a predictive set of algorithms that can be operationalized using these high resolution weather forecast models, have a human in the loop. DTN employs over 140 operational meteorologists, and we feel that when you bring together artificial intelligence and machine learning with an expert human in the loop, you get the best outcomes. So the meteorologist can be responsible for defining that significant weather impact window. They're responsible for defining what are the predominant environmental and weather factors that are going to contribute to outages, and they can establish that time window of most interest. Ultimately, then, the machine learning outputs outage predictions that are tailored to specific operating geographies that a utility is making decisions against as far as resourcing, pre-positioning, and response. The different types of outcomes from outage prediction models are incidents or damage, customers impacted or customers out. You can then take downstream and build estimated times of restoration and resourcing driven models to a great level of granularity. Next slide. So I want to illustrate now the differences between a community outage prediction model like Storm Risk Analytics, which we're going to speak to in detail today, and a utility-specific outage prediction solution like DTN Storm Impact Analytics. The training data sources are different. With a community model where you want to implement outage prediction across broad scale geographies above and beyond just a specific utility service territory, you're going to leverage public or third-party available outage data sets. There's a number of sources now from government-sponsored and run repositories and third-party vendors that are oftentimes scraping or having direct connections into the power utility publicly facing outage maps. So we've taken over 7 to 8 years now of that data in order to build up a really comprehensive set of customers out training data for Storm Risk Analytics. With the utility-specific model, you get the advantage of having that proprietary direct access to an outage management system so that you can gather specific data around incidents and damage and provide a broader set of predictive metrics. The advantage, though, of a community model and Storm Risk Analytics, what we're speaking about today, is the coverage area. You're able to get continental and regional scale outage predictions as opposed to just a focus on your own operating companies or service territory. The limitations, however, the training data leads that customers impacted is the only direct predictive measurement possible in a community outage prediction model solution, albeit there are assumptions that could be applied in order to link that back to expected amounts of damage. With utility-specific models, you get the added benefit of that damage data. At a spatial resolution, we're able to run community models down to a county level, whereas utility-specific models can vary depending on how high of resolution of weather modeling and outage management system data you have available. Of course, then there's always trade-offs in performance versus price, and community outage prediction modeling capabilities are broadly affordable and can be onboarded immediately, given the fact that they're trained on a publicly set of available data, whereas utility-specific solutions often times include an onboarding period with the setup and training against proprietary data. Ultimately, each of these outage prediction modeling approaches results in very high performance levels of predictive capability that hasn't been available to the utility industry until very recently. We're going to have some awesome case studies coming up from Brad and Pat as far as the performance of DTN's community outage prediction model, Storm Risk Analytics. So with that, I'll pass it back to you, Brad.
All right. Thank you very much. I'll take over the presentation here and share my screen. Okay. So thank you, Nick, for providing your expertise and background information on the state of the U.S. Grid investments, resiliency challenges, and state of the science around outage prediction. Let me move my window here. Just one moment. There we go. Thank you. All right, so what I'm going to talk about today is enhancing your existing GIS infrastructure with Storm Risk Analytics outage prediction and how this seamlessly integrates within the Esri environment. So, okay, so this is really all, when you think about outage prediction, you think about grid resiliency, preparation, mitigation, response around weather for for infrastructure and utilities. Really, it's not just about the weather, right? It's not just about the forecast and understanding the forecast. It's how it's going to impact my infrastructure. So utilizing the best in class forecasts like DTN, and we've made significant investments in our global gridded forecast. You overlay that, for example, on your assets, your infrastructure, your personnel, and then using Esri tools, ArcGIS, for example, and in the Velocity application, you can drive critical decisions using geospatial analysis. So integrating weather with geographical data, infrastructure condition, historic outage data, real-time monitoring, vegetation management. That's where a storm risk analytics solution comes in to enhance your predictive accuracy, and it shifts from that reactive to a proactive approach in grid management, as Nick had mentioned. So I'm going to talk about a couple case studies over the last few years. Likely some of these you know of or you're aware of because they were major hurricanes, tropical systems that impacted the utility grid in Florida and much of the Southeast US. And I want to show how our DTN Storm Risk Analytics performed. So this was Hurricane Ian in 2022. Had widespread power outages, over 4.29 million electric customers that lost power during the hurricane. It was a massive restoration effort, over 42,000 linemen deployed to restore power, reconnecting nearly 2.6 million customers during that time. And then the infrastructure damage, so extensive damage to power lines, transformers, other utility infrastructure. If you look on the left here, 2 days before landfall, our Storm Risk Analytics solution predicted 4.59 million customer outages. 1 day before landfall was 4.42. So you're looking at a 7% and 3% variance compared to the actual 4.29 million customers outages. So that did really well, and really our Storm Risk Analytics was in its early infancy of our machine learning days. So this was a case that we could use to further enhance the modeling that goes into the data science and the outage prediction. So it only really gets better from there. I mean, if you look at the right-hand side, this is the on the far right is the number of outages on the scale by county. and looking at the Storm Risk Analytics solution on the top image to compare to the actual number by county in Florida from September 28th to October 4. They line up pretty well. Actually, we were very pleased with that initial case that was utilizing the Storm Risk Analytics in the early stages. Let's fast forward a couple more years and let's look at last year. And this happened to be a pretty major, impactful system where you had two back-to-back hurricanes. Started out a quiet year in the tropical Atlantic tropical basin and in the Gulf than originally forecast, but these back-to-back storms really turned into an uptick in the devastation with huge swaths of the southeast U.S. as hurricanes Helene and Milton unleashed their powerful winds, heavy rainfall, and widespread flooding across multiple states here. So the combination of both of these storms really disrupted quite a bit of infrastructure, displaced communities, stressed emergency resources. There was over $35 billion in damage due to the two storms and over 6 million customer outages. So while the formation and track of these storms really cannot be prevented, we can forecast that. Utility companies can embrace outage prediction, predictive weather intelligence using a machine learning or AI-based risk outage tools, really to help make confident decisions and make incident command, storm impact decisions before, during, and after these major events. So I'll follow with what happened, a look at Milton that followed Helene and how outage prediction helped restoration crews to the pending risks while they were continuing the restoration efforts from Helene. Okay, so Milton comes in short while, 2 weeks after Helene, knocking out power to over 2 million people, houses and businesses in the Southeast. Really pounded Florida and Georgia with the most intense rainfall and high winds as well. Rapidly gained intensity to a Cat 5 in the Southern Gulf in less than 48 hours, and then made landfall near Siesta Key, just south of Tampa Bay, as a Category 3 storm. Really caused significant damage, over 120 mile-per-hour winds, a storm surge of 15 feet, widespread flooding. There was even a tornado outbreak, if you recall, before that storm made landfall the day before making landfall there in Siesta Key. So it ended up being the second most intense Atlantic hurricane ever recorded that originated all over the Gulf. So Milton was really a beast, and compounding that devastation and the recovery efforts of Helene, really Milton made it so challenging, much more challenging to restore power. This is a view of our radar scope, high resolution radar archive, showing the eye of Milton making landfall here in Siesta Key on October 9th, 2024. A lot of rain, high winds on the northern side of the system, and then the feeder bands pretty clearly evident here, and the eye making landfall. All right, so Milton, as I mentioned, had caused widespread power outages. I'm going to focus on Florida. Left about 29% of the entire state without electricity the morning after a landfall, and over 3.3 million customers that had lost power. Those critical decisions related to positioning and repositioning response crews and restoration resources 3 to 5 days in advance of the hurricane, utilizing our storm risk analytics solution, really assisted the utility industry and the preparing for another major hurricane and the resources that were needed. Already stretched thin those resources were, and having that precise information was crucial. So the accuracy, DTN Storm Risk Analytics, days before Hurricane Milton made landfall, had an accuracy rate of 83%, predicting 3.9 million outages 5 days before, and then 3 days before had an astounding 98% accuracy of just over 3.3 million, which is very, very close to what the actual outages that occurred. So a huge success for our for the model. We've seen additional successes as well as the machine learning and is utilizing the historical weather information to further enhance the capabilities of the model. So quite proud of where our where it has come. So taking a look at the outage prediction forecast on the left here in one of our Twitter posts, I believe, or X posts, and then the actual outages from Power Outage US on the right. You can see the colors and the severity along with the scale are quite similar as well, the actual outages. So that 3.3 million, and even down to the county level on how they match up pretty well. So overall, Storm Risk Analytics is a key component of the holistic storm risk suite, including storm impact analytics, energy event index, for example, and then bringing our human in the loop with our meteorologists as well. So bringing this all together, like coupling that with DTN's ArcGIS Data Services, it's a real scalable solution combining weather intelligence and machine learning to help utilities confidently make instant command storm impact decisions then. So, and it's been shown that utilizing an outage prediction model like Storm Risk Analytics, utilities can reduce that outage duration time by as much as 50% by effectively sizing and staging crews. You just can imagine how that cuts down on the duration of not only the length of the outages for your customers, but also the incredible cost savings that can be added to that as well. So, all right, now looking at Esri, like using Esri applications, like you know, essentially like Velocity or using other Esri tools within these applications can provide significant value, and it's really easy than trying to build out your own solution. For example, by quickly and easily integrating DTN's storm risk data into like a powerful Esri tool, GIS platform, your decision makers can visualize and analyze weather risks. Esri GIS tools enable users to perform advanced spatial analysis on storm risk data and your assets. DTN's data can be integrated into Esri's real-time GIS capabilities. This allows you to monitor storm risks as they're evolving. Customize risk assessments using DTN's SRA data with your own proprietary data within Esri's applications is a huge value. Enhancing the visualization of mapping and tools that can transform DTN's data into clear, kind of intuitive visual representations. And then the predictive modeling, using our modeling capabilities and forecast data within your organization's predictive models to anticipate future storm risks and your potential impact. And then the robust reporting tools within the Esri environment can generate comprehensive reports, which are extremely important. And scalability. As your organizations grow, your company needs change, the growing with DTN and Esri can scale accordingly with near 100% uptime, low latency, and incredibly fast response as well. So here's a quick look at a 7-day forecast of our storm risk analytics in our ArcGIS portal. On the right is the 0 to 10 scale, showing the severity on day 2 of storm risk analytics. The reds, orange, reds, purples are top of the chart, meaning there's a high likelihood for significant outages for these individual counties across the central US in this case. Storm Risk Analytics does update in our ArcGIS environment within our data set 4 times per day. It's by county, the predictions by county. So a baseline blue sky day compared to a severe impactful day. You can predict the number of outages compared to that baseline normal outage. In this case, on the right, a normal blue sky day is over 2,700 outages. And then we are predicting over 100,000 in Dallas County, Texas with this event. So that's a 9 out of 10 scale in the prediction. On a normal day is a 2. So you get both. You get both in the Storm Risk Analytics solution, the actual predicted number of outages, and then my risk level on a 1 to 10 scale, showing just essentially a quick look at how good or bad your day is setting up 1 to 7 days out. It's available as a map image and a feature service data. So the feature service data, the underlying data, can be utilized within your applications to run your own geospatial analysis and run reporting. And then how to access that, it's a REST endpoint through our DTN ArcGIS portal, which is hosted on our ArcGIS server. So we provision you, we set that up, and then you can access that endpoint through our portal. All right, quick look at a real Esri dashboard. This happens to be for a telecom company. This showcases our Storm Risk Analytics outage risk index on a 1 to 10 scale. Again, 1 being the lowest, 10 being the highest of outages. What they're doing here is geospatial risk analysis on their assets. They have hundreds of thousands of cell towers across the United States. So they can drill down to a county, as they're doing here, level to get the risk of outages, potential infrastructure damage, utilizing SRA. And the use cases here include they need to pre-position fuel, generators, restoration crews well in advance of these type of systems. So it's not just severe weather, thunderstorms, tornado events, high winds. Tropical weather is a huge major concern for these cell towers and these telecom companies globally. All right, so utilizing outage prediction in an Esri application like this, like Velocity, offers significant value. It's easy, integrates diverse data. You can integrate weather data, infrastructure condition, historical outage data, and real-time monitoring for a plug-and-play solution of potential outages and risk. Showcase real-time processing, so you can filter, enrich, transform the data for analysis and visualization, and then monitor, track alerts. You set up your own alerting tools as well for stationary and moving sensors and just things that just happen as well. So things that pop up within your zone of concern, different infrastructure, your people, your trucks, your assets. This connects to ArcGIS, cloud environments, web and messaging service, other data providers, and then it's fully customizable. So in regards to your time, assets, data, metrics, and logs that you set up. So with that, I am going to go into a live demo. So let me bring up my screen showcasing what we have going on today. This happens to be across the South Central US. And we do have a severe weather event ongoing. This is day 1 customer outages. The legend is on the right from the 0 to 49 to over 250,000 outages in the red. And we're kind of at the middle to top end of the scale here in regards to forecast outages. What do we have going on today? If I turn on the North American radar within our ArcGIS portal, there's a lot of weather going on across Texas. With the severe weather outbreak, there's actually a severe thunderstorm watch and a tornado watch here in the state of Texas into the lower Mississippi Valley. And that's the reason why we're seeing an uptick in outages across this area of Texas. So clicking on the map here, you're able to get the granular details essentially of how many outages are occurring by county. and then also the actual risk index on a 0 to 10 scale. So if I look at just the risk index and bring up day 1, here's your look at essentially the number of outages on a 1 to 10 scale for this this area of the country. So showing my properties 0 to 10, pretty severe, you know, looking at a pretty extreme day here in areas of East Central Texas, where we're up in that 6 to 10 storm risk range for this county. Van Zant in Texas, we're looking at an 8.4 prediction out of 10. So pretty severe day. A normal day is 81 outages for this county. And we're forecasting, due to the thunderstorms in our DTN forecast, 716 outages across the county here. And so we move down towards State College, Brazos County, Texas, another 8.6 day. Normal day is 90, and we're forecasting 614 outages. So that's a live view of our storm risk analytics. And then just looking at on a national scale, as I mentioned, we can get everything from, if you want a day 3 view nationally of outages across the United States. Here's a quick look at that. And then if you're looking more for a 7-day view, here's out to day 7 based on the forecast weather from DTN's global proprietary model. All right, so with that, I will pass the presenter ball back to Kevin and hand things over to Pat Hull, who's Esri's Director of Electric Industry Solutions. And looking forward to hearing Pat's insights and expertise as well. Thank you.
Thanks, Brad. Really appreciate it. That's some incredible data that you've showed there, and I appreciate the heads up. I'm not going to contact any customers in Central Texas today. I think they're going to be fairly busy. Well, I've had an exciting career working for utilities since I was a young person, and I'm currently on the Esri utility team. Appreciate being on this webinar and welcome everybody. DTN is a valued business partner working closely with Esri to help make this incredible data available to our customers. And weather is a big deal. I don't know, have you ever seen something like this? Separate weather monitors or even the cable TV weather channel on in the storm center. When I ran operations, we often had to take all kinds of different information, including weather, with staffing and workload, and integrate them in your head in order to decide what to do. And just a checkpoint here, are we seeing my slides? I don't believe I'm seeing them.
Let me share slides. Share. Is it sharing?
Yeah, there we go.
All
Awesome.
right.
Yeah, thank you. So thankfully, as we've been seeing now, there's much better tools. We saw how this data drops right into the ArcGIS stack that most utilities are already using to manage their infrastructure and their operations. And I would say the true advantages of using better weather data and analytics are improved situational awareness, the ability to optimize your workflows from both a planning point of view and a response, and ultimately, of course, improving the service and communication to our customers and our stakeholders. Now, we deal with weather every single day. Wind and rain directly impact our ability to work safely, particularly on energized equipment. High winds exaggerate fire risk in some parts of the country. Extreme temperatures always drive peak loading on critical equipment, but we're never more sensitized to this problem than when a storm hits. And winds affect workers and overhead equipment and trees that are near lines. Up north, ice is a big concern, lightning, flooding. All of these create issues and potential outages that require a well-executed response. Next slide, please. I have a question for you. Have you ever seen a utility office or a storm center without maps? I have not, and I bet you have not either. Utilities use GIS to model their electrical system, to manage their assets, and also manage their work. And when bad things happen, people need maps. You've seen it. People stand around maps looking and trying to make decisions both at a strategic level, like Brad mentioned, holding crews or calling in crews, requesting mutual aid early, and the ever important corporate communication to your executives, to the news, or to customers. At a tactical level, we make decisions about staffing and resources, where to stage materials, where to focus damage assessment, and where to send crews first. So overlaying weather data on the model of your system is critical in deciding these things. And the resulting insights, they then drive productivity and efficiency gains and go directly to improving, maintaining at least, or hopefully improving those reliability metrics and make the entire system much more resilient to Mother Nature. Next slide, please. I think it's fair to say that digital native employees and customers expect their utility to be using the very best available technology in these critical moments. But it's non-trivial to scale some of these barriers to entry. We've seen a little bit of this. There's large volumes of data from multiple sources. There's wrestling with how to analyze that data quickly and turn it into insights that we can use to help optimize our process and our workflows. Resources, always an issue, particularly in organizations with limited budget and expertise in this area. I'm glad you pointed it out because AI is advancing so rapidly. I try to keep up, but it seems like something new comes out every single day. And when that happens, that creates a need internally for ongoing updates and training just to try to keep pace. And then when you try to integrate data and systems, that adds complexity. And if it's not straightforward, then introduces lag time and actual adoption where you can see the benefit of those things. So this stands out to me as a true benefit of what you've showed so far, as DTN is managing this data with their own resources and expertise and making it readily available for easy consumption within the entire ArcGIS system. And that brings the latest technology directly to the user to apply to their work. I'm glad you showed a dashboard because I attend a lot of events in my work and I speak to many different people. And the relatively straightforward dashboard, I would say, is arguably one of the most potent ways to make that vital weather information readily available to a wide variety of users and decision makers across the utility enterprise. Next slide. Integrating this weather data into the ArcGIS system is really next level. Rather than another system and another place to look, another thing to check, it can be right there, integrated into the very best system information that you have, along with considerations for your community and your customers, allowing you to make the right decisions at the right time. You know, we hear a lot about analytics, but it actually starts very simply. Visualizing is the first building block to analysis, and it's right there on your storm dashboard. You get early warnings that enable you to prioritize specific areas that'll be hardest hit for adequate resources and communication with your stakeholders. I know when I was in charge of operations, the news was always calling, and they always wanted updates. What do we expect to happen? How many people are we going to hold? And it's so powerful to be able to make those kind of decisions earlier in the process and with a high degree of confidence. It's very impressive to see the high degree of confidence in your predicting those things days ahead of time. And then after the fact, evaluating those patterns, it helps us find vulnerabilities that support our system improvement plans and our hardening efforts. Next slide. So as we come to a close here, GIS reveals the patterns that help utilities manage their systems and to optimize their operations. And using live and predictive weather information right there in ArcGIS, visualized on top of your infrastructure and your customer base, is just light years ahead of the traditional methods that we've used for years. That approach reveals vulnerabilities, and then it helps you strengthen your system hardening efforts as well. And finally, it's very efficient from a timing and workflow perspective, allowing us to be more proactive in planning ahead and executing on those critical weather insights. Kevin, are we ready for some questions?
All right, I think we are ready for some questions. Thank you, Pat. I think, before we step in the questions, just one thing just to emphasize here, I think we heard a lot about the latest technology platforms, which Esri as the, market leading kind of GIS platform. We talk about the mapping, the spatial analytics. We've at DTN been a 20-year partner with them as we kind of leverage, all our deep analytics around, the artificial intelligence. So I think if you look at that overall stream of decision making, leveraging modern technology to be able to bring those decisions forward to make quicker, faster, and better decisions, that's the value of the DTN and Esri relationship here. So thank you everyone on our panelists here to kind of walk through from the overall basics overall to the demo and how our relationship works together. So starting with a question here, there was a question here around integration, right? There was kind of a mention of how seamless this is into ArcGIS. And maybe this is a question for you, Pat. It sounds really simple for our services to be able to be hosted up through ArcGIS Online or through our enterprise system or whatever version of software. Can you give a little bit of insight of what an engagement process and how simple that is for an end user or utility would be able to work with that?
Sure. Well, Brad pointed out that these things are available as a feature data service. So that means that they are directly, essentially drag and drop into what you're already doing in ArcGIS. You could be up and running in an afternoon looking at that information. Now, Brad alluded to some advanced analysis and other things that would potentially take a little bit more work. But once that data is viable in ArcGIS via a live service, it's really straightforward GIS operations and work that your people are used to doing every day. And I think you can make some tremendous progress very quickly. And putting those things on a dashboard that you could put in your storm center is something that you could spin up in an afternoon.
Yeah, that's great to hear. And I think, from your side, Brad, if you wanted to make a quick comment about the provisioning of the data into the tool, I think that's a fairly straightforward process as well.
Absolutely, Kevin. Yeah, so essentially, once we are able to get a main point of contact, whether that be your GIS developer or whoever needs to access the data to bring in your applications, I can set that up in minutes within our portal, and then essentially you are set to go in reaching that that REST endpoint within our ArcGIS portal. So it's ready to go, plug and play, and that data can be accessed immediately. And then one thing I did want to mention is that DTN's here with 24/7 support as well. So we have global support for any kind of assistance or questions you have with the data, the implementation, anything we can help with that authentication type process as well. And then we rely on Esri as well as a valued partner to help with the actual integration into your environment. So overall, it's every entity kind of getting the best out of the data sets, biggest return on the data that you can as an organization, and working together through that process.
I think that's the beauty, Brad. You've done all the hard work. You've made it readily available to customers to plug right into what they're doing.
That's the goal. Yeah, that's the goal. That and many of our other data sets as well. We want to make it as seamless and easy and plug and play as we can.
Yeah, that's great. I think, in today's environments, decisions have to be made quickly, and they have to be made in a very good fashion, and this combination really highlights that. The next question here, and I think this question maybe goes back to you, Nick, is, with the changing of climate and the frequency, you were showing some different charts in the beginning about, the increasing in weather outages. Are there any new features or capabilities in development from your team to kind of capture these ongoing and changing patterns? There's a number of different weather and different perils. Any insight you can kind of lend into that to make sure that we're evolving as the weather evolves?
DTN's looking in a number of different innovation pathways. I think first and foremost, it's important to continue our investment around this historic gridded weather capability, because that serves as the underlying training reference point for any future AI and machine learning oriented solutions. We're investing a lot of time and money and effort, as well as co-innovation partnership with many power utilities, to look at how we can continue to advance peril-oriented intelligence. So when you think about a significant weather event, you can think about it in context of just the significant wind risk alone, the significant flood risk, different elements that contribute to the overall asset and infrastructure and ultimately power outage impact. And we want to start to build out multi-variable or parameter hazard and peril-oriented indices. So we've started down this pathway with wildfire-oriented risk, combining both environmental as well as fuel factors. We're thinking about and have recently announced the introduction of a hurricane threat index, which incorporates the different elements as far as wind, storm surge, heavy precipitation and flooding, as well as tornado risk, and have similar ambitions with flood, severe convective storms, air quality and dispersion. So we're excited about how the application of these advancements can improve the situational awareness and preparedness for utilities.
Yeah, great, Nick. I think, just to emphasize something you mentioned there, you mentioned multi-variables at once. You said flooding and wind, or hail and wind, or surge and rain. Many times it's not just one particular weather element or one particular peril, it's the combination. Anything you can kind of enlighten us on around, the data science capabilities there? I think Pat had kind of mentioned, nearly every day there's new AI components, there's new modeling. I know you work closely with the data science team under your leadership. Any kind of insight you can get about that evolving pattern within DTN to leverage so that kind of multivariate view?
Mm-hmm. Yeah, I think DTN's been really forward-looking as far as the design and architecture of our underlying global forecast system. We take a weather model and AI modeling agnostic approach. We incorporate the best of what's available everywhere in the world and apply AI and machine learning in order to weight the top performant models. So as new image matching and processing models that have been touted from NVIDIA, Google, and other tech leaders come to light and bring advantages in certain short-term forecasting situations in certain parts of the world, we can incorporate that content into our global forecast system and power all of our peril-oriented intelligence downstream in order to provide the best benefits and incorporate advancements in technology. So we're really excited about the advent and opportunity that AI is bringing as far as improving the assimilation of observed weather data, the incorporation of remote sensing, the ability to downscale and provide higher levels of granularity of weather and environmental impact directly to your assets. And those are all things that we're looking forward to taking advantage of and passing along within your solutions.
Great. Thank you, Nat. So to kind of take this to the bottom line, the so what as you speak, you can hear how DTN is evolving its science. We're really applying that science. We're creating useful insights out of that science that is then being worked into market-leading software such as Esri. And we're able to do that, as you heard, in a period of an afternoon. So, you know, pretty powerful tools that together here as our partnership, we're able to work through. And so I thank everyone from joining today. We are at time. Questions we were not able to answer, we will absolutely respond to you. And as Andrea mentioned at the beginning, we'll be sending the link around for this recording. If you can please take a shot of the QR code here, and you know, we can connect a little bit more with the experts to keep the conversation going. Again, thank you very much for joining. No time is valuable, and appreciate you joining us today. Thank you.